Hello everyone, welcome to the lecture series on electromagnetic theory and transmission lines. In our previous class we have discussed about the Coulomb's law and we have solved some problems. Now we will see the new topic, that is the electric field. So it is also related to the point charges and the equation of the electric field is taken from the Coulomb's law only. And in future we are going to apply this particular electric field concept to another charge configurations like point charge, surface charge, volume charge, like that. First we will start with the point charges only. So you assume two charges are available in this particular diagram. So Q1 is the first charge, Q2 is the second charge, and the position vector of Q1 is given by this particular R1, the position vector of Q2 is given by R2. And already we know Coulomb's force equation. Now I am going to write Coulomb's force equation, which is giving the force on Q2 due to Q1. So F12 is equal to 1 by 4 pi epsilon, product of the two charges we have to take, that is Q1 Q2 by what is the distance in between these two, that is R or R12. So magnitude of R12 cube into R bar. This is the thing we have taken. If you want to use the unit vector, then here R12 cap, and in the denominator you will be having only the magnitude of R12 cap will be there. So here the electric field concept is about whether the charge Q2 is available or not available in the location R2. The effect of Q1 will be available. Okay, in the position R2, whether Q2 is available or not available, the effect of this particular Q1 charge will be available around the Q1 actually. So for example, this is the position x2, y2 and z2, and Q1 is available at x1, y1, z1. So whenever Q2 is available at x2, y2, z2, then we have given the force equation, and now I am saying that electric field is also available. Okay, electric field E12 I am taking, that means electric field at position 2 due to the charge available in position 1. Now in position 2 Q2 charge is available. What is the equation for this one? Means in this particular electric field, what is the source charge, only that charge is available. So we will take like this, 1 by 4 pi epsilon, Q1 is the source charge, so Q1 by magnitude of R12 cube into R12 bar. Now I am telling that Q2 is not available now. Here Q2 in the first case, case 1 I am taking here, Q2 is available. In case 2 I am saying that Q2 is not available. Q2 is not available in position 2, that means at x2, y2, z2 the Q2 charge is not available, even though in that position the effect of charge Q1 is available. That effect is called electric field. So 1 by 4 pi epsilon Q1 by magnitude of R12 cube into R12 bar. The same equation we are using, whether Q2 is available or not available. So irrespective of the availability of the charge Q2 in position R2 or P2 or at the position x2, y2, z2, whether the Q2 is available or not available, the effect of charge Q1 is available in the position R2. That is the thing we are going to discuss. So if you relate this force equation and this electric field equation, how can we write how can you get the relation between these two? Means what is there in the right hand side of F12 equation, Q1, Q2 both charges are available, and 1 by 4 pi epsilon in the denominator magnitude of R12 cube and the vector R12 bar is there, and everything is there in the electric field equations also, but only one charge is available which is responsible for the effects, that means Q1 charge is available. So due to Q1 we got the force on Q2 in the Coulomb's law. Now what we are doing in the sense, from the Coulomb's law only we are getting the equation for the electric field, that electric field is due to Q1 charge only, but here the interesting point is whether Q2 is available or not available. at that position x2, y2, z2 the electric field is available. So, if you send q2 charge in the force equation from the right side to the left side, what you will get, F12 bar by q2 is equal to, the remaining part is 1 by 4 pi epsilon q1 by magnitude of R12 cube into R12 bar. This is exactly equal to your E12 bar electric field. This is exactly equal to E12 bar. So, this is what we need. So, due to the point charge q1, what is the electric field? Means 1 by 4 pi epsilon q1 by magnitude of R12 cube, that is multiplied with the vector R12 bar. Otherwise, we can write like this also, in terms of the unit vector 1 by 4 pi epsilon q1 by magnitude of R12 square and R12 cap, that is equal to E12 bar. Or in terms of the position vectors also we can write how we have written for the Coulomb's law, same thing we can able to do. And whatever the problems we have solved in case of the Coulomb's law, similar type of problems we can able to do for the electric field due to the point charge problems also. Okay. So, this is the thing, and here also we can able to apply superposition principle. That means you can take another charge, for example q1, q2, and here q0 is there. On q0 we can get the electric field due to q1, and on q0 we can able to get the electric field due to q2. Instead of saying on q0, we can tell at the position of q0 we can able to get the electric fields due to q1 and q2, because q0 is not available in the equation of the electric field. Whether the q0 is available or not available at this particular position like x0, y0, z0, you will be having the electric field whether the q0 is available or not available. So, because of these two charges you will be having the electric field like this. So, the resultant electric field is given by the vector addition of these two electric fields. So, it is similar to Coulomb's force only, force equations only. So, what is the equation here we can able to give means E0, the electric field on the charge q0 or in the position of q0, that is x0, y0, z0, we can give E0 is equal to 1 by 4 pi epsilon naught q1 by, if you take it is R1 bar and it is R2 bar, magnitude of R1 cube into R1 bar plus 1 by 4 pi epsilon q2 by magnitude of R1 cube into R2 bar. So, like this we can able to write. You can take here 1 by 4 pi epsilon as common and you can able to write the remaining equation. Now, we will see one particular problem. A positive charge of plus q coulombs is at 0, 0, 3. That means it is available on the z axis. Its x coordinate and y coordinate both are zeros, and at z is equal to 3 this particular charge is available. It is a positive charge. It is a positive charge, plus q is available at 0, 0, 3, and negative charge minus q is available at 0, 0, minus 3. It is also on the z axis only, because x coordinate is 0 and y coordinate is 0. The electric field at 400 is required. 400 means it is on the x axis. So, what we will do in the sense, here we will take z axis is here, this is the x axis, positive x axis, it is positive z axis. So, y axis is coming out of the screen like this, it is y axis. So, what we will do in the sense, we will represent the point charges, given point charges now. At 0, 0, 3, for example, it is 0, 0, 3 on the z axis, here plus q charge is available. At 0, 0, minus 3, we have minus q. Now, the resultant electric field we need on the x axis at 400. So, here for example 400 is there. So, we need the electric field because of these two. So, first I will find the electric field due to the charge plus q which is available at 0, 0, 3. So, the electric field at point 400 is along the line which is joining those two positions, that is 0, 0, 3 and 400. So, it is along in that particular line direction, and the electric field due to the charge minus q which is available at 0, 0, minus 3 at the position 400 is along the line which is joining those two points, So, like this it will be available, and this type of situation already we have seen in case of the Coulomb's law, here also same thing. So, the resultant force equation will be available along the positive x direction or negative x direction, means that we have to be more careful here. Here the electric field direction is along the line joining, but we here second charge is the negative charge. Negative charge means it is having the converging nature. So, the direction will not be available away from the negative charge, it is towards the negative charge. So, what we need to do in the sense here, the arrow mark should be taken into the negative charge, like this we have to take. Okay. Now, due to the positive charge the electric field direction is like this, due to the negative charge the electric field direction is like this. So, what is the resultant direction? Surely it is available in the negative z direction, like this it will come. So, they are not asking about the electric field magnitude, they have asked about only the direction. So, here already we got here negative z direction. So, in this manner we have to solve. If you are interested in the magnitude also, we can able to calculate that one, that is using the equation E bar is equal to 1 by 4 pi epsilon the charge q by magnitude of r cube into r bar. So, in all these problems first we have to calculate the distance vectors only. So, due to charge q1 I am calculating r1 bar, that is observation point minus source point. 400 is the observation point and source point is 003. So, 4 minus 0 is 4, 0 minus 0 is 0 and 0 minus 3 is minus 3. And due to minus q, what is the distance vector is nothing but r2 bar, and here in this case the observation point is same, that is 400 and source point is 00 minus 3. So, observation minus source we have to do. 4 minus 0 is 4, 0 minus 0 is 0 and 0 minus of minus 3 is plus 3. So, this is R2 bar. So, R1 bar, R2 bar we have, then we can able to proceed for the resultant E bar, and here we need magnitude of R1 bar also, that is equal to square root of 16 plus 9, that is equal to 5, and magnitude of R2 bar, that is equal to 16 plus 9, that is also 5. So, E bar I am writing here, this is equal to E1 bar plus E2 bar, because it is following the superposition we can able to take this particular thing. So, E1 bar plus E2 bar, E1 bar is due to the charge plus q and E2 bar is due to the charge minus q. So, it is equal to 1 by 4 pi epsilon, and due to plus q I am calculating plus q by, I am taking R1 magnitude of R1 cube into R1 bar plus 1 by 4 pi epsilon magnitude of second charge, that is minus q, by R1 R2 cube into this is R2 bar, this is the thing. So, it is equal to, we can take 1 by 4 pi epsilon as common and its value in free space is 9 into 10 power 9. Okay. Then q is nothing but its value is q only, they did not give any value. So, we have to take q only by, what is the magnitude here, 5 cube, and here we have 4 0 minus 3. Next remaining thing is minus q by magnitude of R2, that is 5. So, again 5 cube, and here we have R2 is 4 0 3. This is the thing we have. Now, if you observe here, x components will be cancelled. Here plus 4 is there, here minus 4 is there, x components are cancelling and there is no y component, and here z component is having the negative value and here z component is also having the negative values, that means minus z. Orally we will be having the minus z direction only, that is what we have told without doing the problem also. Here itself we have given the conclusion by doing the vector addition process. So, here also you can able to perform that one. So, it is equal to 9 into 10 power 9, and in these two now I can take common q by 5 cube is also common, and in the first case we have minus 3 az cap, and in the second case we have minus 3 az cap. So, it will be minus 6 az cap, you can able to solve this one. Okay. And if they have given the q value, we will be having some exact value of the E bar. So, in this manner we can able to solve. Now, we will see the next problem. ABC is an equilateral triangle charges plus q are placed at each corner. This type of problem already we did in case of the Coulomb's law, but here the thing is we need to show the electric field intensity at the centroid of the equilateral triangle is 0. Okay, that one we have to show. So I am taking here one equilateral triangle, this is the x axis, y axis I am taking, then this is the equilateral triangle. So this is x axis and this is y axis, this is 0 0, and I am assuming the side of the equilateral triangle is A. So side is equal to A. So this length is A only, that means here A comma A 0 is there, and this is our equilateral triangle, this is 0 0, and up to here it is A by 2 and it is A comma 0, and here x coordinate is A by 2 and y coordinate means we need to use the Pythagoras rule. So you do not know this value, okay, sorry, this value is A because it is one of the side of the equilateral triangle, we do not know this value. So x is equal to, we can tell, square root of A square minus A square by 4, that is equal to root 3 A by 2, this is the thing we will get. So this is the x value, that is root 3 A by 2, okay, this is the thing. Now centroid is nothing but, here it is available that centroid is dividing this particular line in the ratio of 2:1, in the ratio of 2:1. That means here this particular point P or the centroid C I am taking, centroid C I am taking, the centroid C coordinates, what are the coordinates means, we have x coordinate is A by 2 only, but y coordinate we have to calculate, that is root 3 A by 2 into 1 by 3, because that centroid is dividing that line in the ratio of 2:1, that is why I am multiplying with 1 by 3. So what we will get, A by 2 root 3 we will get. So here y coordinate of the centroid is given by A by 2 root 3, but another property is there for the centroid, that is from the vertex to the centroid the value is, the length is equal to side length by root 3, that means A by root 3, it is A by root 3, it is A by root 3, you can check that one. Okay, so this is the situation now. So here we can write now A by 2 comma root 3 A by 2, and here the centroid is available, and centroid coordinates are A by 2 comma A by 2 root 3, that is also available, and from the centroid to each corner or each vertex of the equilateral triangle the length is A by root 3, that already I have told. Okay, now what we need in the sense, at the centroid we have calculated the total electric field due to the 3 charges which are available at the 3 vertices of the equilateral triangle, plus q plus q plus q, this is the thing. So I am giving the numbering here, this is 1, this is 2, this is 3, and centroid is represented with C. Total electric field is equal to electric field due to the charge which is available in the position 1 at the centroid, that means 1C, E1C and E2C, that is the electric field at the centroid due to the charge available in the position 2, plus E3C, this is the electric field at the centroid due to the charge available in the position 3. So because superposition theorem is applicable for the this particular electric field point charges, because it was derived from the Coulomb's law, and Coulomb's force equation is satisfying the superposition principle, that is why we can able to apply that rule here also. So E1C, if you write the equation for that one, in all the 3 equations we have 1 by 4 pi epsilon, and in all the 3 equations the same charge is available, that is q, that can also be taken common, and the distance is also A by root 3. So A by root 3 also we can able to take common, A by root 3 whole cube, this is the thing. Here what is the remaining thing, distance vectors we have to write. So distance vectors I did not calculate till now, and now I am going to calculate. So first distance vector R1C is equal to everywhere observation point minus source point only, from the Coulomb's law onwards I am telling. So here in case of R1C, our observation point, everywhere observation point is A by 2 comma A by 2 root 3, and source point is here in this case 0 0. So observation minus source point, if you write A by 2 comma a by 2 root 3, like this will get. It is x component, a by 2 is the x component and y component is a by 2 root 3. Next R2C, R2C is nothing but what we need to take, it is a distance vector in between the centroid and the second charge. Second charge is available at a comma 0, that is the source position, and observation position is a by 2 comma a by 2 root 3 only. So, the difference in between these two will be given by a by 2 minus a, that is minus a by 2 comma a by 2 root 3 minus 0, that is a by 2 root 3. So, like this will get. Then R3C. So, observation minus source, observation is again a by 2 comma a by 2 root 3 and source is nothing but now position 3, that is a by 2 comma root 3 a by 2. So, if you subtract these two, what we will get, a by 2 comma a by 2 is nothing but 0 and a by 2 root 3 minus root 3 a by 2, this is the thing. Now, if you subtract these two and the LCM is here 2 root 3, that means here a we will get, and here root 3 is 3 a, that is minus 2 a by 2 root 3, that is minus a by root 3 will get. So, this is minus a by root 3, this is the thing. Okay. Now, here distance vectors only we have to write. So, if you write that one, first distance vector is a by 2 ax cap plus a by 2 root 3 a y cap. Second one minus a by 2 ax cap plus a by 2 root 3 a y cap. It is better to write these unit vectors also, otherwise you will be confused. So, I am including these vectors also. And then third one is 0 into ax cap is 0 only, minus a by root 3 a y cap, this is the thing we have. So, a by 2 ax cap minus a by 2 ax cap both will be cancelled. Next a by 2 root 3 a by 2 root 3 means a by root 3 a y cap, and here minus a by root 3 a y cap is there, these three will be cancelled. So, nothing is there here, 0 into something is 0, that is the thing. So, we have proved that. So, we have proved that the electric field at the centroid due to the 3 charges available at the corners of the equilateral triangle is 0. Thank you.